In this presentation, I'm going to show a summary of the responses of an early Rhynchospora alba and a late Molinia japonica colonizer to solar radiation in a boreal wetland after peat mining. The study was conducted by Ayumi Hirata and Shiro Tsuyuzaki, Graduate School of Environmental Science, Hokkaido University. This paper investigates the responses of Rhynchospora alba and Molinia japonica to different solar radiation in post-mining Sarubetsumaer, northern Japan. The key findings of this study are: in 2008, R alba and M japonica did not change their biomass, but in 2009, R alba decreased its root and shoot biomass, and M. japonica decreased its root biomass. Chlorophyll concentration did not change for the early colonizer, while it changed for the other with changing solar radiation. Rhynchospora alba adapted more to strong solar radiation, while M. japonica responded more to peat moisture. In this slide, the study area and materials for this study will be discussed. The study was held in 2008 and 2009 at Sarubetsumaer, northern Hokkaido, Japan. Peat was mined in this site in the year of 1982. Rhynchospora alba and Molinia japonica were studied as early and late colonizers respectively, because these two species are quite dominant in early stages of succession in peatland. After growing the seedlings of these species in greenhouse, they were transplanted on the bare ground every year. Now, the plotting for planting the seedlings. On the bare ground, two 8 meter into 8 meter plots are made, and in them 25 0.8 meter into 0.8 meter subplots are made. To shield different ranges of wavelengths, different films and shear nets were set above 20 cm to 25 cm from the surface of the plot. The films are perforated for allowing rainfall penetration. Here we find 5 kinds of solar radiation treatments. One is ambient, which is without any obstruction. Natural light will enter directly into the plot, and others are covered UV, UVB, and shaded treatments. However, in 2009, random plots were excavated to increase the peat moisture of the plots. Now, statistical analysis that were used in this study. Allometric relationships between the root and shoot biomass was compared with ambient conditions with the analysis of covariance. The effects of treatments on plants were compared by a generalized linear model. Gamma distribution was found for the biomass, total chlorophyll, chlorophyll AB, and anthocyanin, where binomial probability distribution was found for UVA and UVB absorbance. Here, we find the figure for allometry between root and shoot biomass in the two species. The solar radiation was higher and rainfall was lower in 2008 than in 2009 during the survey period, with many other differences. In 2008, only the effects of solar radiation was examined, and in 2009, with these effects, 2 moisture conditions were also examined. R alba increased its shoot biomass under low UV and under shade. In 2009, the allocation patterns for them remain unchanged throughout the time. However, M. japonica did not change its allocation pattern in any root treatment in 2008 and 2009, but it allocated more to shoot biomass under wet condition in 2009. Chlorophyll and UV absorbing substances in the species. Chlorophyll A to B in Rhynchospora alba decreased under shade and low UV, where chlorophyll concentration in M. japonica increased in the same situation. Molinia japonica continuously produced ultraviolet absorbing substances even under low radiation. The ultraviolet absorbing substances of Rhynchospora alba responded quickly to changing solar radiation. It may be because they have to expose themselves to high changing solar radiation to establish themselves in the early stages of successions in the bare peat ground. Anthocyanin was low in Rhynchospora alba, so it was not the main UV absorbing substance. To conclude, it can be said that early colonizer, R. alba in this study, responded more to solar radiation, and late colonizer M. japonica responded more to peat moisture. This study suggests the consideration of climatic variability in understanding the plant responses to solar radiation. It also suggests a long-term field monitoring, since plants may adapt to dynamic extreme radiations. Thank you.